So today we are going to see the question that we have is 783, and the question is saying that the question we have given is minimum distance between the BST, the binary search tree, right? We have given BST. So in the binary search tree, we have given the root of the binary search tree we have given, and we have to return the minimum distance between the value of the any two different nodes in the tree, right? So if you'll see the example, right? So example first, what we have given, the roots are given here, and we are returning the output 1. Okay, so we'll see how this will work, and how we will find the minimum distance, you can say, between the binary search VST node, right? So to understand this concept, right, to let's try to understand the approaches, right? So that we will do the you can say uh, implementation. Okay, so we'll come back here and we'll understand. So this question has been asked in the, you can say, Hang, that is Amazon, Microsoft, Google, right? So this question is very important, because if Google has asked, then something is good, right? So let's understand here the in order traversal with a list, right? So we'll try to solve a simpler problem first, so we'll understand the concept. So we have a given sorted you can say array of integer, and we have to find the minimum distance between any two integers in the array. So to solve this problem, what we will do, we do not need to check every pair of the integer. Instead, we will checking the difference between every two consecutive integers would work. So this is because the every array is sorted, and let's say the array is we have 1 1 3 7 8 like that, and if we have if we say we will fix one integer, we say 7, then its closest element would either be the element on its left or right, that is 3 or 8, and hence for all the element except for this one, we will check the difference of the element on its left, and find the minimum of all its differences, right? So let's consider this you can say array, and do the useful differences, right? Let's suppose we are going to do this first, 1 and 3. So if we'll do 3 minus 1 will come 2, and similarly if we'll do this 3 and 7, it will come 4. Similarly we'll calculating these are differences is coming with all the consecutive. So if we'll put all the differences into our array, right? So this will look like this one, right? So if you'll see the minimum element in this outcome, it is array, that is nothing but our 1, right? So now you have understand that this is the way after the you can say after getting the differences, we have this one, right? So we have checked the difference with the element on its left, and what we have did, we have find the minimum of all such differences, right? Then in the our original problem, we have some integer values, that is called nodes value, and we need to find the minimum difference between any two values, right? And thus the original problem is similar to the problem that we have just discussed, and if we keep these values in the sorted order, right, we can easily convert the original problem into above one, right, that we have seen. So there is in order traversal of the binary search tree that produces a sorted array, right, and therefore we will generate the in order of the given tree, and then we will find the minimum difference using the order, right? So what we will do, there is one thing, like if you consider this example, right, any of the example. So for the in order, right, in order means what, we have left, right, and you can say uh, left, root, and right, we will go with in order. So if you check the in order traversal right here, so if we'll do the sorting, right, so after the sorting, what it should come, let's suppose after the sorting will come 1 2 3 4 5, like this will come, right? So the minimum is what, 1, and that's why we are getting what, 1 as a output. Similarly, if we'll talk about this one, what we have, this is given. So if we'll do in order traversal, so after the in order traversal, let's suppose we are getting 0 1 48 12, like this we are getting, right? So whatever the data will come here, the minimum one, that will be our answer, right? So what we will do, we will say, what we should say, we will have our the first approach, right, in which we will see have some integer value, node value, and we need to find the minimum distance between any two. So the original problem is similar to the problem that we have discussed, and if we keep these values in the sorted order, so we can easily convert the original problem into the above one that we have discussed. And in this traversal, you can say, of the binary search tree produces sorted array, therefore we will generate the order in order traverse in order array of a given tree, and then we will find the minimum difference using the algorithm just we have just seen, right? So we'll try to find the differences, right? So as you can see, if this is the thing we have, right? So if we'll do this, if we'll do the sorting, right? So after the sorting, if we'll prepare the differences, right? So 2 minus 1 is what we are getting 1, 3 minus 2 is getting what 1, 4 minus 3 is getting what 1, and 5 minus 4 is getting what 1. So each time what we are getting 1 1 1 we are getting. So minimum element if we will try to find this one, so coming 1 only, and that's why the output is 1. Now if we'll talk about this one, so if we'll do like this, 48 sorry 12 is coming, then 48 and 49 is coming, right? So if we'll do 1 minus 0 is 1, 12 minus 1 is 11, and 48 minus 12 is something, it will come 6, and it will come 24, let's suppose, and similarly it will come some value. So some value is nothing but more than you can say 27, let's suppose 27. So in this, this element is smaller than anything else, right? This is 11 we have, this is 26, this one, so one is smaller, and that's why we are getting this value, right? So in this way you can find your output, right? And you can do the needful things, right? So first of all, what we should understand here is that, so if you'll do the anything, that what we need to do, our some difference, we have to create some difference array, we have to find the minimum element, right? So in our approach, what we will do, we first initialize the minimum distance to max value, and then we will do the will perform the in order traversal of BST, binary search tree, and we'll store the nodes in the list that is called in order nodes, right? And we'll try to iterate over the in order from index 1, and then each element of the I will do the difference I minus 1, and we'll update our mean distance accordingly, and we will return the mean distance, right? So what we will do initially, first we will take one list that is in order traversal node, and what we will do, we will apply the in order, we will create one in order function, and then we will we will apply. So we have created root equal to null, then first we will go with left, then we have the root value and the right, that is we said, right, left root, and then we'll go right, right, left, right, root and right, that is our in order, and that's why we are going with left, uh, root and right, right. So these three are happening here, that is in order, in which we are updating our nodes each time here. So this node is will this node list will get updated each time here, right? Or internally we are calling first left, so it will go to this left node. Internally the we are doing we are iterating each time, right? Now coming to this one, now our this node is prepared using the in order traversal, right? This node is sorry, this list is ready. You can say the array that we are talking about, right? So this array we are ready with the minimum value, right? Now we have the minimum element, right? So to find the minimum element, what we have to do, in order we did in order, we have sorted our you can say nodes, and we nodes are sorted now. So you got our in order traversal nodes in the list. Now what we have to do, we'll take a minimum distance as a max value, and we'll iterate over the all the nodes. I will start from 1 to last node, and what we will do, we'll find the minimum. So we'll find one minimum distance. Minimum is, we have taken the max one, and the traverse things, right? So we'll define the differences, right? I and I minus 1 at this index, and let's suppose this index. From this index we'll do minus this index, so we'll get some values, and whatever the minimum will come, then we will return as a minimum, right? So in this approach, what will happen, we will get our time complexity on, because number of nodes is n, and for space complexity we are calling the each time the stack, each time will go to its consecutive, you can say all the nodes, right? As you can see here, right, for this one. So all the nodes will get traversed, right, for the stack, and so that it will also on as a time complexity. Now we are talking about the in order traversal without the list, okay, in which we are not taking any list, right? What we will do, we will have a minimum distance, and the previous node through we will check the value. So previous node value we will take, and what we will do, we will take the in order traversal similar way that we have already discussed. This is our in order traversal, sorry, give me a minute. Okay, so now we have created the in order traversal, right? So we will take similar, in the similar way. In order we'll passing root dot left, and then we are passing root, right, and root dot right. So left, this is for left, root, and left, sorry, right. So that is our happening, right? So only we have to check the previous node value not null, then we will find our minimum from the root minus previous value, and whichever will come minimum, that will store down here, right? In this way, what will happen, your minimum distance will get updated each time, and then from the, you can say, from the root to it's all the nodes, right? We'll find the minimum node, which one is minimum, that minimum each time we will update our minimum, right? So here you can see minimum is getting updated each time, right, from the all the previous one. And then actually we are calling this one, so this method is get called, and finally we will return the answer, right? So that's all we have for today, and time complexity will remain same for the on, as the number of nodes we have given, and the height of tree is depends on the stack, right? So that the space stack calls, and so that space complexity is OFH, that is the height of the tree, right? So if you think this video help you, and if you like more videos like this, so please like, share, and subscribe this channel, so that you will get more updated videos, right? Thank you so much, guys. If you like this video, please hit comment, subscribe this channel. Thank you so much.